All right, number 15, I'm going to give you a confidence level, and then I'm going to ask for a p-hat and a margin of error. So let me pull up a little spreadsheet here. And this is really just understanding what these numbers represent. So we've already done the calculations ahead of time, and we got the end result is 0.27 and 0.35. Okay, so what we have to think about is when we calculate a margin of error, when we calculate a confidence level, we've got a point estimate that we're adding and subtracting the margin of error to. So our point estimate, or that sample p-hat, is dead center of 0.27 and 0.35. So what I'm going to do is I'm just going to add those two numbers up. And then, oops, let's try that again. Let's add them up. I don't know what I thought I typed in initially. And then I'm going to take that number and divide it by 2. And so right in the dead middle of that is 0.31. So that's my sample proportion. And my margin of error is to take one of my endpoints and subtract out the middle. Put an equal sign there. So my margin of error in this case is 0.04. Now the nice thing is I can go both directions. I can just take the 0.31. Let's learn from my mistakes here. So equals 0.31 minus 0.27. And I should get the same number. So whether I do the big number minus the middle or the middle minus the small, I should still get the same margin of error. Okay, number 16 and 17 are both asking about sample size. Both of those are formulas off the formula chart. One of them is dealing with proportions, and the other one is dealing with means. And so once you've looked up those formulas, then it's just a matter of plugging in the right numbers and typing it in your calculator or Excel. Okay, so you can kind of see both cases. These formulas are on the formula chart. You don't have to memorize them. The one thing you do have to recognize is whenever we calculate sample size, we need to round up. Whatever we're given, we always round up. All right, so one of the most challenging topics towards the end of statistics is we're given a lot of distributions to have to decipher between. So it's always helpful, we might not think that way, but to review older distributions and make sure we understand the differences between how to recognize normal versus uniform versus discrete and binomial. So the last two questions here deal with material that was on the second unit, and it's mainly just to make it so that when we see it on the final, it's not that thorough a shock for us. So number 18, 57% of cat owners greet their pet before spouse or children. If 20 cat owners are randomly selected, then what's the probability that they come home no more than 6 will greet their pet before greeting their spouse? Okay, so this is a textbook example of a binomial distribution. We're given a defined probability of success, which is 57%. We are given a fixed value, so there's 20 total cat owners, and we want to track whether it's 6 or more. Now, binomial CDF is the same as like norm CDF, so in other words, when we work in those questions, we want to make sure they're in terms of less than as well. So in this case, since it's asking 6 or more, then we want 1 minus the binomial CDF of 6. I'm sorry, not 6, 5. So binomial distribution, it's going to ask for the number of trials. Well, let's take a second and clarify this. No more than 6 means 6 is the max. Okay, so I do want up to 6. There are 20 trials. The probability of success is 0.57. And just like norm CDF, I want true for binomial CDF. And so I get 0.98 for the probability. Okay, sorry, I just caught something just as I was saying it here. No more than 6 means 6 or less. So 6, because it's or less, then I don't need the 1 minus out front. Okay, so there's probability. About, what is that, 1% of the time. And then the very last question is a review of a discrete distribution. All right, so we've got defined values of 0, 1, 2, and 3. Probability that goes with that, so 0.2, 0.6, 0.15, and 0.05. Okay, so to find the mean of this, then I'm going to take the probability, x times p of x. Now, again, this isn't there's a formula chart that you'll get that will remind you of the Excel commands for this, or the calculator commands. So that number times that number, and then I can just drag that down. It will multiply all that for me, and then to find the mean, then I want to do is sum that up. Okay, so given this scenario, then I would expect the average value to be about 1.05. Okay, then to calculate standard deviation, there's a new column we're going to need. So we're going to need x squared times the probability of that. Okay, so equals the observation squared times its probability. And I'm going to drag that down. And this time I need to sum that as well. Okay, and I'm going to take, then I need to square this number, square the original mean. And then I want to find the difference between those two numbers. And then I want to square root that. And that'll tell me the standard deviation for this discrete distribution. Okay, and last but not least, probability that they own 2 or 3 calculators. So go back up here. Probability is for 2 calculators 0.15. Sorry, equals 0.15 plus the probability of owning 3, which is 0.05. So the likelihood of them owning 2 or 3 would be the 0.2 there. So hopefully this helps.